Hi guys, welcome to this page of the notes, and again what we're doing is we're taking a look at that first objective or learning target we have where we want to solve logarithmic equations. And I've got a couple of great examples for you here of logarithmic equations. It's an equation because I have an equal sign and I have a variable. I have something I don't know and I need to solve for that variable. Well, the way that these are going to go is we're going to rely on our old friend Snail Method. Snail Method is going to help us solve these every single time. It's the quickest, easiest, fastest way to do these, guys. So here we go. Let's jump right into it. We know we're going to need the Snail Method. Start with the base. Work your way around the equal sign. If you feel like it, go ahead and finish off that snail. Draw yourself a cute little snail. Put little antennas on him. Give it eyes and ears. Remember, he likes to meow. Meow. But anyway, the way the Snail Method works then is I'm going to have 36 to the 3/2 power is equal to x. So Snail Method allows me to rewrite this as 36 to the 3/2 power is equal to x. Now, if you want to, this is actually now very, very easy to do, right? You just do 36 raised to the 3/2 power on your calculator. Or remember, rational exponents, the denominator becomes the index on the radical. You could also write this as 36 cubed and then take the square root of 36 cubed, whatever. It gets you the exact same answer. You should wind up with 216. X is equal to 216. So what that means is 36 to the 3/2 power is 216, or the square root of 36 cubed, 216, whatever, same thing. Got a couple more for you here. Let's see how these go. Again, it's got to be the Snail Method. Work our way around. Finish it off if you want to draw yourself a cute little snail. I love it. 9 to the 3/2 power is equal to x. Again, you could simply rewrite that as a 9 cubed and take the square root of it because the denominator becomes the index of the radical. Either way, in your calculator, you'll get the same answer. Either do 9 to the 3/2 power. I put the power in parentheses, though, so your calculator doesn't mess up the order of operations. Or just put in your calculator square root of 9 cubed. Whichever, you're going to wind up with x equals 27. And I got one more here just for good measure, but I think you guys get the idea. I told you Snail Method was going to show up in every single chapter, or in every single section for this chapter, or the remaining sections for this chapter. It will. So we'll Snail Method. It's going to get that x all by itself, isolate the x, and so I wind up with 16 raised to the 5/2 is equal to x. Again, remember, the 5 remains the power, the 2 becomes the index, and so what I've got here, this is exactly the same thing as 16 to the 5th power. Take the square root of it, right? These guys mean the exact same thing. I don't care which one you put into your calculator, 16 to the 5/2, or do the square root of 16 to the 5th. It's the exact same thing, and you should wind up with x is equal, sorry, I apologize, I'm squeezing here. I got a calculator right here. I come up with 1,024 as my answer. Sorry, I apologize, I'm squeezing there. Anyway, really, really easy problems. These are super simple logarithmic equations where all I got to do is isolate the variable, and the Snail Method works perfectly for isolating that variable and then allowing you to evaluate the expression that you've written. So, Snail Method, solving logarithmic equations. Now, jump down here. I got a couple more for you. This is going to be the logarithmic property of equality. Guys, you should recognize this. We did an exponential property of equality just a couple of sections ago. The way it worked is it said if the bases of the exponential functions were the same, then we could set the exponents equal to each other. Well, here's the property of equality for logarithms, and here's what it says. As long as the bases for the logarithms are the same, log base b, then you can set the arguments, what you're taking the log of, equal to each other. So log base b, that will only be true if and only if x is equal to y. So as long as the bases of the logarithms are the same, just like with exponentials, if the bases were the same, set the exponents equal to each other. Same thing here for logarithms. If the base of the logarithm is the same, then you can set the arguments equal to each other, right? X equal to y. Let me highlight it for you. Really, really important, but hopefully you should fairly easily see the correlation between exponentials and logarithms, and it should make perfect sense. Exponentials and logarithms are inverse functions, right? So a lot of it's going to be the same kind of thing. Anyway, here we go. Let's go ahead and do these. I got a couple of great problems for you here. I want you to solve log base 2 of x squared minus 4 equal to log base 2 of 3x. Well, right away, we get an opportunity to practice the property of equality. I have a log base 2 and a log base 2. Because the bases are the same, set the arguments equal to each other. So that's exactly what I'm going to do. X squared minus 4 is equal to 3x. Now all I have to do is solve for x. Well, in order to do that, I'm going to move the 3x over to this side. That way it'll be set equal to 0. This should kind of jump off the page at you. Back in chapter 4, we spent the entire chapter solving quadratics. And you have an x squared. This is going to wind up being quadratic. Minus 3x minus 4 is equal to 0. I know it's been a while, but all that stuff we did as far as factoring in chapter 4, definitely need to remember how to do all of that. It's going to come back. Here it is right here. I've got x squared minus 3x minus 4. I'm going to try and factor it, where hopefully it'll factor nicely into two binomials. If it doesn't factor into two binomials, then I may have to do the quadratic formula or completing the square or something like that. But I do think this one's going to factor nicely for me. I need two things that get me x squared. Well, the easy bit would be x and x, right? X times x gives me x squared. The trickier bit, I need two numbers that multiply to a -4 and sum to a -3. Well, actually, that's not that bad. If I did a -4 and a +1, right? -4 times a +1 is a -4. And -4 plus 1 gets me my -3. Remember the way it works, you need to be able to multiply these guys to get that last number and add these guys to get that middle number. If you've forgotten anything about factoring, just go back to chapter 4. We did all of our factoring in chapter 4, sections 3, 4, 5, and 6 was where we covered factoring quadratics. It wouldn't be a bad idea to go back and just review those. Anyway, it's multiplication, so zero product property lets me split them up and solve them both. Now, I get two answers, x equals 4 and x equals -1. What you've got to be careful of here with logarithmic equations is extraneous solutions. Extraneous solutions is just a really fancy way of saying a solution that doesn't actually satisfy the original equation. It doesn't work. So you will need to check your answers. And I'll just let you know the easiest way to do this is this. Remember I said when we were looking at graphing logarithms, you cannot take the log of a negative number. If you don't believe me, pull out your calculator, go ahead and do a log base 10, just hit the log button, do a -1 or a -2, -3. Pick your favorite number, just take the log of a negative number, your calculator will freak out at you. Lights will go off, horns will sound, stuff like that. It doesn't like it. It's because you can't take the log of a negative number, and that's because we have that vertical asymptote that restricts the domain of the logarithm. There are certain values of x that you can't plug in, negative numbers being one of them. So all you need to do to check your solutions is just check to see if one of them is giving you the log of a negative number. And really quickly I find it. If I plug a -1 in for x, -1 times 3 is a -3. I cannot take the log of a negative number. And so very easily I have found my extraneous solution. I know which one is correct. And I have solved my multiple choice problem. Hey, let's do another one. All right, here we go. I have the log base 3 of x squared minus 15 equals log base 3 of 2x. The logs and their bases are the same. This is the equality property of logarithms. I set the arguments equal to each other. X squared minus 15 is equal to 2x. It's quadratic. It's going to be quadratic. We're going to have to factor, but that means I need to get everything on the same side and set it equal to 0 so that I can factor it. X squared minus 2x minus 15 is equal to 0. Now, with any luck, right, it'll factor into two binomials. If it doesn't, I may have to use the quadratic formula or complete the square, something a little trickier. But let's see if it factors into two binomials first. Maybe my life will be easy. I don't know. We'll see. The easy bit, I need two things that multiply to give me an x squared. That's an x and an x. The trickier bit, I need two numbers, multiply to 15, sum to a negative 2. Well, actually, that's not that tricky. Minus 5 and plus 3. Negative 5 times a positive 3 is minus 15. Negative 5 plus a positive 3 is a negative 2. So it does factor nicely. Zero product property will let me split them up. Once again, I'm going to get two answers, and I'm going to have to check them. It's totally possible that both of them could work, but it's also possible one of them may be extraneous. And actually, it's not that hard to tell. Negative 3, when I plug it in, 2 times a negative 3 is a negative 6. I can't take the log of a negative number. So this one is no good. This one's my winner, and I have solved my multiple choice problem. Guys, hopefully what we've done here makes perfect sense when it comes to solving logarithmic equations using the equality property of logarithms. It's very similar to what we did with exponentials. It's just now you have logarithms. Head on over to the next page of the notes and we'll take a look at a few more problems. I'll meet you guys over there.